Thank you for joining me today for my podcast in which I will be talking about the oldest long-span suspension bridge in the world still in use, the Wheeling Suspension Bridge. Science has always strived to make headway in transportation to provide effective communication. This struggle for facilitating transportation led Charles Elliott Jr., an American civil engineer, to think outside the box and come up with innovative ideas. In the year 1849, he came up with a design that has left a revolutionary impact on the world of civil engineering. The Wheeling Suspension Bridge, connecting eastern and western section of the National Road between West Virginia and Ohio, making it the oldest suspension bridge in the world still in use. The span of the bridge is 1,010 feet from the summit of tower to tower, leaving the entire width of this river unobstructed. The summits of the eastern towers are 21.75 feet above the western towers. The highest elevation of the flooring is immediately over the channel of the river, where the top of the flooring is approximately 92 feet above low water, whereas the lowest flooring is at the western end, approximately 62 feet above low water. The uniqueness of the structure comes with the wrought iron flooring supported by cables which are anchored by a succession of links, like those of a huge chain, into massive walls of masonry-built towers. These cables are 1,380 feet long from one fastening to the other. On top of the towers, the cable rests on cast iron rollers which adapt themselves to any movements of the cables occasioned by changes of temperature or transitory loads. The flooring is supported by 12 iron cables suspended from the towers, 10 large and 2 small ones. The large ones contain 550 strands of number 10 wires and the small ones 140 strands. A total of 12 such cables, each 1,380 feet long, having used a total weight of 455,400 pounds of wire. These cables were laid out parallel to each other in the main street of Wheeling and salvaged, which means that they were tightly wrapped with more wire around them to increase the tensile strength of the cables. The cable wrapping process is carried out in 4 steps. Initially, the cable is wound around with a rope, then a wire, and then finally savaged with more wire. Due to this savaging of the cables, the strength of the bridge, as computed by Mr. Elliott, is sufficient to resist 297 tons or 32 heavy-laden road wagons, 192 horses, and 500 people, a weight equal to an army of 4,000 men, greater probable weight than it will ever be required to sustain. This wrought iron structure truly brought about a revolutionary change in the world of civil engineering, inspiring the creation of landmarks such as the Statue of Liberty in 1886 and the Eiffel Tower just 2 years later in 1888. One should visit this revolutionary landmark to truly appreciate this remarkable work of engineering.